right, we are going to work on the steps for long division. And so I'm going to show you the example that is in your curriculum. And that example is 343 divided by 7. So when we look at each part of this number, we're going to start by asking ourselves, how many times can 7 go into this number? So the question is, how many times can 7 go into this number? All right, so one of the ways that we look at that is we actually look at the 7 times table. That's exactly what it means. It's the times. So we know that 7 times 1 equals 7. We know that 7 times 2 equals 14. 7 times 3 equals 21. 7 times 4 equals 28. 7 times 5 equals 35. 7 times 6 equals 42, and we'll see if we need to keep going on from there. So the first way that we approach this is we look at the first number in our dividend. This is the number that's being divided. Can we divide 3 by 7? Well, looking at this, we know that the opposite of multiplication is division. So the opposite or inverse of multiplication so I know that 7 divided by 7 equals 1. I know that 14 divided by 7 equals 2. I know that 21 divided by 7 equals 3. I know that 28 divided by 7 equals 4. And I know that 35 divided by 7 equals 5. So I can't get very close to 3 without going over. I can't get close at all without going over. So I can't do 7 into 3. Now I have to look at the first two numbers. Can 7 go into 34? How close can we get without going over? Well, when I look at these numbers off to the side, you can either look at it like this. The product is going to be less than 34. I could do 7 times 4. Or if I want to look at it this way, my dividend has to be less than 34. I know that I can do 28 divided by 7 equals 4. So if I do 34 divided by 7, I know that it will go in 4 times. That 4 times 7 is 28. And I can then subtract. Remember, dumb mermaids swim backward repeatedly. We have done the division, then we've done the multiplication. Now we have to subtract. That's the swim part. So I can't take 8 away from 4, so I have to take it away from 14. I'm going to have to borrow from the 2. 14 minus 8 is 6. Okay, so I've done my subtraction. Backward means I have to bring down the 3. And then I repeat my process. So I have to divide, I have to multiply, I have to subtract, I have to bring down if necessary. So right now I need to find out how close can I get to 63 without going over. Well, I know that 7 times 7 equals 49. I know that 7 times 8 equals 56. And I know that 7 times 9 equals 63. If I want to do the opposite of that, remember, I can go over here and look at the product, and the product becomes my dividend. So we were at 35. Now I'm going to go 42 divided by 7 equals 6. 49 divided by 7 equals 7. 56 divided by 7 equals 8. 63 divided by 7 equals 9. So if I look at this 63, I can see that I can divide 63 by 9, or by 7, 9 times. Again, now I'm looking at the 63. I can divide 63 by 7 9 times. So when I divide, I place the answer up here. Now I have to multiply. What is 7 times 9? 7 times 9 is 63. The next step is to subtract. I'm going to subtract 63 from 63. 63 minus 63 is 0. Now I don't have any more numbers that I need to bring down in this problem. So I am finished with 343 divided by 7. My quotient is 49. Remember, our quotient is the answer to a division problem. This is our quotient, our dividend, and our divisor. Now, looking at that, we can do, again, larger numbers using whole numbers, and we can work with remainders. So let's try another large number. Let's try 1,286, 1,286 divided by 21. Again, when we look at this, we can do a couple different things. We can go ahead and make our multiplication times tables off to the side. 21 times 1 equals 21. 21 times 2 equals 42. 21 times 3 equals 63. 21 times 4 equals 84. 21 times 5 equals 105. 21 times 6 equals 126. Ooh, we're getting close. 21 times 7 equals 147. 21 times 8 equals 168. 21 times 9 equals 189. If we want to do the opposite of that, we can go back through and do 21 divided by 21 equals 1. 42 divided by 21 equals 2. And we just keep going through and doing this. 63 divided by 21 equals 3. 84 divided by 21 equals 4. 105 divided by 21 equals 5. 126 divided by 21 equals 6. 147 divided by 21 equals 7. 168 divided by 21 equals 8. 189 divided by 21 equals 9. All right, so I am on 1,281 divided by 21. So again, what I did was I went ahead and wrote out my times tables. Then I went ahead and I switched it over and I wrote out each of these products as a division problem. So when I look at the first number, I say, can 21 go into 1? No, we can multiply 1 times 21 and it equals, but we can't divide 1 by 21. So remember that this symbol says that whatever is underneath it, we are dividing by this number right here. So then I come over here and I highlight the 2. Does 21 go into 12? No, 21 does not go into 12. So I'm going to go ahead and continue and go over to 128. 128 divided by 21. I know that I can do this. The closest I'm going to be able to get to 128 is 6. 126 divided by 21 equals 6. So the closest I can get to 128 is actually 126. So I'm going to write my 6 on the line, and I'm going to do 6 times 21. 6 times 21 is 126. 126. Now I'm going to do my subtraction. So I divided first, then I multiplied. Now I'm going to subtract. 128 minus 126 is 2. Now I'm going to bring down my 6. When I bring down my 6, that's 26. Does 21 go into 26? Yes, 21 can go into 26 one time. 21 times 1 is 21, and we're going to subtract. 6 minus 1 is 5. 2 minus 2 is nothing. Now, I don't have a decimal point on this one, so I can't continue on into the other place values to see if I can go any further. So this piece that's left over, there are 5 pieces that were not evenly distributed. So that becomes our remainder. 61 remainder 5 is our quotient for 1,286 divided by 21.